Hey there, my name is Abhishek Nandgaonkar. I'm from Mumbai, India, and currently a graduate student at the Northeastern University. The topic of discussion today is person of interest. Crimes are on an all-time rise. Terrorist attacks are happening all over the world. New terrorist outfits are being found by the month, and these outfits no longer attack on a small level. However, crimes on the smaller level have increased too. Homicides, rapes, thefts have all become irregulars in the dailies. With technological advances and its ready availability, the criminals have become smarter. An innovative smart advent to tackle the new age criminals is the need of the hour. Take a look at the statistics here. These are mind-boggling and scary on so many levels. This paper here proposes preventive and reactive measures to counter the criminals by maintaining a database of criminal activity-related tags for investigation and hot word detection of day-to-day conversations preempting crimes from occurring. Security is taken very seriously given the rise of the crimes that have been taking place. Closed-circuit cameras have been put in place at every nook and corner to monitor the activity being carried on in a particular area. In case of any activity that the federals need to monitor, they have to fetch the footage for a particular set of cameras in the said locality and go to the footage for any activity that they feel is suspicious. But this entire activity requires a lot of manual effort as well as the human involvement for identifying the suspect and monitoring the activity. Along with the cameras, we suggest the use of audio recording devices. These devices record the audio and provide for processing. The processing would include identifying individual conversations, converting the speech to text, comparing the words fetched from the hot word dictionary, and flagging the conversations if they are found suspicious. The flagged conversations can then be manually viewed by federals on the CCTV footage and determine if they have to act on it. And voice are two essential factors of the human body that can be used to identify one. Biometrics have always played a crucial role in security. Iris detection, fingerprint, and palm scan are just a couple of examples of the multitude of applications where biometric is used in real life. While most of these biometrics can identify the individual from up close, the entire face can be identified from an image taken from a few feet away as well. This paper uses the concept of intelligent storage of the CCTV footage videos where the individuals in the footage are identified and the videos are then tagged against the individual profile. This would be used in the future when the particular person's name comes up in the investigation and the federal government needs information about the person's previous whereabouts and interactions. Additionally, we suggest implementation of a hot word dictionary, which would be a collection of individual words, combined words, phrases, codes, and slangs which can be used to indicate a description of a crime or a crime to happen. Having a mix of preventive and reactive security in the form of face detection and speech processing is what this paper suggests would increase immensely the likelihood of crime detection and prevention. The objectives of this paper are maintaining a person profile database, maintaining a hot word dictionary, storing links to all the CCTV videos a person was found in, audio processing to gain knowledge of the severity of the conversation, storing the tags generated from the CCTV video and the CCTV audio for further processing. Concepts that have been implemented in this paper are unique profile maintenance, image processing, face detection and recognition, fetching videos for a particular profile, audio processing, and hot word dictionary. The paper assumes the presence of a unique identification system for citizens of any country. Every citizen would have a unique identification card. From each citizen, basic details like name, date of birth, address would be taken, but along with that, a picture of the citizen would be taken as well. The citizen would have to undergo mandatory profile picture upgrade every 10 years so that the federals can keep a track of the individual's latest picture. The unique profile database would be created on Hadoop HDFS. You can see the approximate table structure in the slide alongside. There would be name, unique identifier, father's name, address, which would link to the address table, date of birth, age, and photograph, which would be stored as an image binary. Shown in this slide is how the image would be processed and stored. The image once acquired would be first converted to its binary format. So the image of this beautiful lady here becomes the series of zeros and ones. The binary format of the image would then undergo compression using RLE-based compression algorithm. Run length encoding is where the occurrence of series of zeros and ones are stored as a single unit, which drastically reduces the size of the file to be stored. This, however, also adds an additional processing overload. The result of this RLE would then be stored in Hadoop HDFS. Face detection is a computer technology that determines the locations and sizes of human faces in digital images. It detects the faces and ignores everything else, such as buildings, trees, and bodies. Cognitech is one of the leading companies that makes face detection softwares. Let's take a quick look at how face detection and face recognition works.
Cognitech, the face recognition company. FaceVax DB scan with examiner. Law enforcement professionals rely on the speed and accuracy of face recognition technologies to help in criminal investigations. Cognitech's technology can quickly identify a face in photographs or images from video footage and compare it to images held in large databases. The examiner toolset in FaceVax DB scan enhances the original image. For example, the pose normalization filter uses 3D technology to create frontal views that will better match the images in mugshot databases. Still images from video footage often display an interlacing pattern, which can be corrected with the de-interlacing filter in Examiner. The application successfully matches composite images to photographs in the database. Face recognition technology allows investigators to instantly find images of the same person, regardless of age, glasses, hats, hairstyle, and facial hair. Cognitech, the face recognition company. FaceVax Video Scan. FaceVax Video Scan employs premier face recognition technology to analyze and identify people in video streams. This groundbreaking technology supports operations management and marketing departments, as well as security staff, in one application. The application captures lossless video footage each time a person appears in front of a camera and stores the clip for continuous comparison and re-recognition.
Processing face detection and recognition. The video feed from the CCTV cameras would be collected every 12 hours. Video processing would be performed on these videos to find unique faces in the video. The individual faces identified in the video would be matched to the profile database. A link to the video storage would be stored to the individual profile. Also, a tag table would be maintained where the tags generated from the video would be stored. Face recognition with local binary patterns, spatial pyramid histograms, and naive-based nearest neighbor classification approach would be followed. The Viola-Jones object detection framework can be trained to perform face detection too. OpenCV would be used for implementation. Local binary patterns approach is discussed here. Local binary patterns is a type of feature used for classification of digital images. Consider the 9 pixels at the top left corner. The center pixel of the 3x3 matrix, that is 9 pixels, would be compared to its neighbors. All the neighbors that have a value greater than the center would be marked as 1, L0. The binary number thus generated and thus LBP is performed to create histograms, and in the end, a long lengthy histogram of all such LBP values is generated. Look at how the video would be stored and how the processing of the video would take place. Look closely. There are two flows, one simply for storage, another for processing. The video once acquired from the CCTV camera would then be converted to binary and then compressed. This compressed video would then be stored to HDFS with the location and the timestamp details of the video. The flow shown above it is where the processing would take place. Face detection would be performed on the video using an OpenCL based algorithm. The faces detected would then be stored to a temporary space. These faces would now be compared to the individual profiles existing already in the system. Each time a profile match occurs, a link to the video is stored to the profile. Additionally, in the tag table, entries related to the face detected profile it belongs to, the video stored location would be stored. This tag table can then be referred to when looking for profiles for a particular face. Let's now take a look at how fetching of videos would take place. Every profile will have links to the video stored. If the federal agencies need information about an individual and they have the individual details, they can simply locate the profile by matching the image. Load up all the links that point to the CCTV footages containing the individual. The federal agencies can then filter the videos by location or timestamp and acquire the videos of interest. Slide mentions how the flow of fetching profile videos would go. Once the image is acquired, we would first store it to a temporary space. Then, if the federals can provide a known or an approximate location, search for the person profile can be started location-wise. Supposedly, if the area mentioned is Longwood area of Boston, the video tag tables of Longwood, Boston would be referred first, thereby optimizing the search. If the profile is not found, the neighboring areas would be referred to. If not, the scope would be increased even further. Once the match is found, the tag entries of the profile can be loaded up, and all the videos of interest would be at disposal for the federals. This paper also proposes creation of a hot word dictionary. The hot word dictionary would contain single words, double words, phrases, slangs, and codes approved by the federal team. These words and phrases would add a level of threat to the conversation. The severity level would be associated with each of the above, comparison with which the severity of the audio would be determined. Tags containing the above data would be added to the tag table as well. The audio tags with the video can then be handed over to the federals and they can look into it if the conversation is of any interest to them. The process of creation of hot word dictionary would be overwhelming. Consider all those words in the dictionary, consider all those slangs, consider all the codes. Adding each of them to the dictionary with the severity level would be one heck of a task. To kick off the process, an algorithm would be generated to read all the dictionary words, and based on the meaning provided, words would be added to the hot word dictionary, along with the synonyms provided. For the double words, phrases, and slangs, an in-depth search can be performed over a series of crime-related websites to get text of interest. Example given in the slide for the hot word dictionary. Now, if the words say supposedly buy RDX come up, the severity of such a sentence would probably be very high. If the words say gun purchase come up, the severity could be dodgy. It could be moderate because guns can be legally purchased in some countries. If a phrase like, oh, you're so dead, give me my toy back, if that comes up, the severity could be low because this is definitely not a sentence that would indicate crime. The severity would be stored as numbers, 1 being the lowest, 5 being the highest. Now, since the words are compared, words are given a severity. And based on all the words in a sentence, the sentences would be given severities. And similarly, the conversations would be ranked if those are severe or not. Let's discuss the audio processing part of the project. The recording of the audio would be done along with the video from the closed circuit television cameras. The audio would be recorded but not stored for privacy reasons. Since the audio would be recorded in areas of noise, noise filtering would be essential. Additionally, since there would be multiple conversations in progress at the same time, identifying each would be very essential. The filtered audio would then be converted to text, that is in individual words for comparison with the hot word dictionary. Audio processing is basically when you talk to the software. When you speak and the software recognizes your speech and converts it to text. When you say Siri, I'm hungry today. When you say okay Google, set up a reminder. When you say any of that stuff, it is speech recognition and audio processing. Examples of two popular tools available today are Dragon Naturally Speaking and CMU Spinks, which is also an open source software. Let's take a look. Let's take a look at a video of how audio processing and speech recognition works.
Phone and start talking. Watch the computer screen and see what happens. This is Dragon Naturally Speaking, speech recognition software that turns your voice into text 3 times faster than typing with up to 99% accuracy, period. Bold 3 times faster. Underline 99% accuracy. New paragraph. Dragon makes it easier for anyone to use a computer, period. Students can complete their homework assignments faster than ever before, period. Busy parents can coordinate schedules, manage email, and even update their Facebook status, all by voice, period.
Now look at the flow of the audio processing. Even here, there are 2 flows for audio processing. Once we acquire the audio from the CCTV cameras, noise filtering would be performed to gain clarity. Post that, individual conversations would be identified. Speech-to-text algorithm would be applied on this. This text output would then contain words, phrases, slangs, and codes, and hence would be compared with the hot word dictionary. Based on the hot word severity, the words and the audio would be marked, and then the conversation would be given a severity rating. This information would then be stored to the tag table along with the video information. Now take a look at the Hadoop implementation. The user profile table would contain the name, which is a string, the unique identifier, which would be a long integer, the father's profile connection, which would again be a long integer, the address, which would be a foreign key to the address table, date of birth, which would be date, age would be an integer, and the photograph would be an image binary. The partition of this table would be based on location. Next up, let's look at the Hadoop implementation of the tag table. The tag table would contain the location as a string, the timestamp as date and time, the file name, the file name for the video and the audio, which would be the location and the timestamp appended, that would be again string. The faces identified would be a binary. The tags would be again string. The profile of the face identified would be a foreign key to the profile table. The video stored would be binary, and the tags from the audio fetched would again be string. The partition of this table would be based on location. Hotword dictionary table would contain the word or the phrase which would be string, and the second would be severity, which would be integer. The range of the severity would be between 1 to 5. The partition of this table would be based on severity. One of the major drawbacks of the current implementation discussed in this paper is the storage of video. Video storage would take up a lot of space. So as an additional scope, we suggest that the tags be retrieved from the videos. We identify the people in the video and generate tags for the same. So face detection is done, the profile is identified, and a profiles tag is made. Now that particular person would act as an object. His interactions with all the other objects around in the particular video would be recorded as different tags and the tag interaction. Supposedly, a person goes to Starbucks, picks up a coffee from the desk, walks to his table, and settles down. Now the interactions would be the person interacting with the cup, walking to the table, and sitting on the table. Now these interactions could be recorded. Similarly, the interactions between two objects, that is two people, could be recorded as tags. So each person becomes a tag, the conversations become tag, and the severity can be added to the particular conversation or the particular scene accordingly. So this way we would be able to discard the storage overhead of videos. The Hadoop implementation would also change accordingly. Instead of video storage, only tags would be stored, which would drastically reduce the space requirement. So in conclusion, it can be safely said that with certain additions to the current setup, the security of people can be beefed up to a very high extent. The solution proposed in the paper provides both preventive and reactive solutions to the crimes occurring. Flagging a video based on audio severity and fetching the video details when needed for investigation would indeed go a long way serving the people better with high level of security. Thank you.